Good evening and welcome to the 8-week tutorial session of EMI EMC signal integrity. I will share my screen. Hope the presentation is visible to all of you. Okay. In the last week, we discussed about the radiated emission model of two conductor system and also three conductor system. We found out the per unit length parameters, per unit length inductance, per unit length capacitance, the self-inductance values, the mutual inductance values, right? All these things were covered. Today we will be continuing with the three conductor system, the different parameters, and after that we will be starting crosstalk model in frequency domain, and also determination of crosstalk in a lossless line immersed in a homogeneous medium. Okay, let's start. The first question is an objective question. For a three-wire conductor line in homogeneous medium, if LC and R represents per unit inductance, capacitance, and resistance matrix respectively, then which of the following statement is or are correct? Okay. So first of all, a three-wire conductor line in homogeneous medium, and LCR represents the unit inductance, capacitance, resistance matrix. Then we need to know what are the properties of these matrices. Whether L is a symmetric matrix, R is a symmetric matrix, L, C is a diagonal matrix. So whenever we are determining crosstalk in a lossless line immersed in a homogeneous medium, we take certain assumptions that the conductor is a perfect conductor. That means it is lossless. And the second one is obviously the medium is lossless and homogeneous. When we are assuming that the conductor is lossless, then obviously R matrix and G matrix will be zero. They will be zero matrices. And what is Z? Z is J omega L. And what is Y? Y is J omega C. This much we know, right? And what is the multiplication of L and C? L and C is mu epsilon I2. What is I2 here? I2 is a unity matrix, right? I2 is a unity matrix. So if I write, so L is a symmetric matrix, this is true. And R is also a symmetric matrix, it is a zero matrix. So obviously it will be symmetric. All the elements of that matrix are zero because it is lossless. And LC is a diagonal matrix. Why? Because LC, the multiplication of L and C that we saw is equal to mu epsilon mu epsilon I2, right? And what is exactly I2? I2 is a 2 cross 2 matrix like this. was 1, 0, 0, 1, right? So this will always be a diagonal matrix because in the primary diagonal elements are unity and other elements are 0. Whatever you multiply with this matrix, always these elements will remain 0. So LC is a diagonal matrix. This is also true. So option D is correct. All the statements are true. Okay. You remember this is from the crosstalk model. Okay, this is from the crosstalk model, and this the assumption is that the medium is homogeneous and the conductor line is lossless. Okay. So we were just discussing the first problem uh, where the properties of the LR and LR matrix, LCR, all these matrices were being discussed. When it is a three-wire line and the medium is homogeneous. This question is a numerical question. Consider a two-wire line placed over a semi-infinite ground plane separated by a distance of 3 centimeter. The height of the generator conductor is 1 centimeter above ground plane and height of the receptor conductor is 1.5 centimeter above the ground plane. Radius of each wire is 16 mils. Determine the per unit length inductance of the generator and per unit length mutual inductance between the generator and receptor. We need to find out what is LG and what is LM. So similar discussion has been done in the course video. Okay, so what do we need to find out? We need to find out the generator inductance LG, the self inductance, and the mutual inductance between the generator and receptor. Right? So what do we do? See, there is a semi-infinite ground plane. There is this generator conductor and there is this receptor conductor. This one is above a height of 1 centimeter. And this one is above a height of 1.5 centimeter. Okay. And the distance between them is given 3 centimeter. So whenever there is an infinite ground, what do? We apply the concept of images. Suppose there is a conductor above some height, so we will assume that there is another conductor exactly at the same height but in the opposite direction, right? This is also at a distance of 1 centimeter from the ground, but this is an imaginary conductor. Similarly, for the receptor, we will take another conductor, another image, which is at a distance of 1.5 centimeter, right? Okay. So what is LG? LG is, this usually we represent in microhenry per meter, right? So for the LG, we can write mu naught by 2 pi ln 2 Hg by Rg. Okay. This is Hg. That refers to the height of the conductor from the ground plane. And Rg is the radius. Okay. So mu naught is 4 pi times 10 power minus 7. And in the denominator, we have 2 pi. So this becomes 0.2 if we take the unit as microhenry per meter, then this becomes 0.2 ln. So this is 2 because Hg is 1 centimeter. And what is Rg? The radius is given. Radius of each wire is 16 mils. That gives us 16 mils is equal to 16 multiplied by 0.001. This will be in inches and then multiplied by 2.54. We will get the value in centimeters. Okay. So this value is 0.04064. This is 0.04064 centimeter. So you put the value over here and you will get 0.779. Okay, so what is LG? LG is 0.78. But 0.78 we are getting in two options, option A and option. I will just show the lecture notes once so that we can understand. See, this is the scenario. Two conductors are there, generator and receptor, and the image conductors. What I just showed you, right? So the self inductance we already calculated. What is remaining? The mutual inductance, right? What is the mutual inductance? The mutual inductance is like this. So this is mu naught by 2 pi ln. What is the maximum distance? This is S1. So we need to consider from ground plane to the conductor. So below the ground plane, we will not consider the flux. Why? Because these are imaginary conductors. So the distance is S1 maximum, and the minimum is from generator to receptor. And then another component is mu naught by 2 pi ln S2 by S3. This is corresponding to this conductor. So S2 is from this conductor to this conductor. The imaginary generator, the receptor, and S3 is from here to the ground. Okay. So if we simplify this, it will become S1, S2 by S3. But we need to find out all these distances. And this is very simple. Just Pythagoras' theorem we will apply and we can find out. Okay. In terms of the known values. What are the known values? The known values are the height from the ground plane. The height of the conductors from the ground plane are given, and the separation between the two conductors are given. So we can find them out in terms of these known parameters. Okay. So finally, this is the expression. Okay. So I will delete this. So our mutual inductance will be mu naught by 2 pi. So this is nothing. We are just representing the distances in terms of the known values, in terms of the heights, and in terms of the separation between the generator and receptor. Right. So this is mu naught by 2 pi, then half ln 1 plus 4 HRHG by a square. Right. All the values are known. HRHG are known. ACE is also known. Substitute the values. So if you substitute these values, HR is 1 centimeter, right? It is given. So generator conductor is 1 centimeter above the ground, and receptor conductor is 1.5 centimeter above the ground. So this is 1.5, this is 1, ACE is 3 centimeter. Okay. Just put the values and you will get LM is equal to 0.051 microhenry per meter. So the correct option is option A. Okay. Let's see the next problem. If the separation between the two wires is doubled, then which of the following is correct? So the value of S was initially 3 centimeter, now it is doubled. Then which of the following is correct? Per unit length inductance of the generator remains unchanged and per unit length mutual inductance increases. Okay, per unit length inductance of the generator remains unchanged and per unit length mutual inductance decreases. Both per unit length inductance and mutual inductance of the line remains unchanged. Both per unit length inductance and mutual inductance of the line increases. So this is straightforward. LG expression we wrote. So LG was equal to mu naught by 2 pi ln 2hg by rg. In the expression of LG, there is no S. This is independent of S. So whether you are whether the separation is doubled, it doesn't affect LG. LG is unaffected. But in LM, you have S over here. This is the separation between the two conductors. So if this is doubled, then this quantity will decrease, right? This quantity will be become 1/4 from the initial value, and obviously then this value will decrease. So per unit length inductance of the generator remains unchanged, that is true, but per unit length mutual inductance decreases. And that is also true. Sorry, just a minute. Yeah, sorry for the interruption. So, what I was saying is that even without calculating anything, intuitively you can understand that when the separation between two conductors is increasing, then obviously the mutual inductance will decrease, right? The more the conductors are more coupled, then the mutual inductance increases. Okay. So intuitively also you can understand that this is the correct option. Option B. Okay. So let's see the next question. Determine the per unit length mutual inductance between generator and receptor if separation between the two lines is halved. Now, what is the case? The case is that the separation is halved. Okay. Okay. So now this is halved. Earlier it was 3 centimeters, so now you will put 1.5. Okay. And rest of the values are same. HR is 1.5 centimeter, HG is 1 centimeter. All the other values will be same. So this will be, you can verify it later. I am just putting the values. So 0.1299 microhenry per meter. Okay, so option D is correct. Let's see the next question. Consider a lossless line immersed in homogeneous medium. Which of the following statement is or are correct? Chain parameter matrix is a diagonal matrix. Diagonal elements of the chain parameter matrix are equal. Cross diagonal elements of the chain parameter matrix are equal. Okay. The chain parameter matrix is phi. So this is a matrix Yeah, my net went off. Are you
The voice has stopped, ma'am.
yeah, are you able to see the screen?
Yes, ma'am.
Yeah, okay, okay. Yeah, so chain parameter matrix is defined to model crosstalk. Okay, so it is denoted by phi like this. Okay. So this is the this is kind of the diagram, simplified circuit diagram. This is a two-port network where this is the source side and this is the load side. We have a source here, and this is the generator, and this is the receptor. And near end, this is the near end side, this is the far end side. Okay. And after multiple matrix manipulation, it starts with this simple equations, right? So with these simple equations, and after further matrix manipulations, okay, so all these equations are defined. You can check it here. In the lecture slides, you will get all the derivations. Okay. I'm not going into this because this is a very large derivation and you can refer to it. See, this is the chain parameter matrix. Okay. That's how we define it. So this is VL and IL, and this is equal to chain parameter matrix phi L multiplied by V0 I0. Okay. Let's see what are the values of what are the elements of the matrix. This is phi 11 L is equal to cos H hyperbolic gamma L. Okay, where gamma is propagation constant, or it is equal to J beta, where beta is the phase constant. Okay. I2 is the unity matrix basically. I wrote it, right? So this is equal to 1001. This is an unity matrix of 2 cross 2 order. And then what is phi 12? Phi 12 is this. Just this is phi 1 2, you can see, right? This is minus j omega L sine beta L by beta L. Okay. And then phi 2 1. You see phi 2 1 and phi 1 2, they are not equal. Because here we have C, but in phi 1 2 we have L, right? But phi 2 2 and phi 1 1, they are equal. So the main diagonal elements are equal, but the cross diagonal elements are not equal, right? See, this is cos hyperbolic gamma L, and this is also cos hyper, like gamma L is basically J beta, right? So this is J beta. What are the options here? We have chain parameter matrix is the diagonal matrix. Diagonal elements of the chain parameter matrix are equal. Cross diagonal elements of the chain parameter matrix are equal. So the only correct option is, so only option 2 is correct. Okay. Chain parameter matrix is not a diagonal matrix. Why? Because in diagonal matrix, except for the main diagonal elements, all the other elements are zero. But here that is not the case. So this is not a diagonal matrix, and the cross diagonal elements are equal. That is also not true. Okay, so next question. Consider the following statements. For a lossless line in homogeneous medium, crosstalk depends on the characteristic parameters of the line. 2 is eigenmatrix is a diagonal matrix. Okay. So I will again request you to refer to the lecture slides and the lecture videos by Professor Amitabha Bhattacharya. There you will find the derivation and also the properties of the matrices. So all these two statements are true. So both statements are correct, and statement 2 is the correct explanation for statement 1. This you will have to listen to the lectures, okay, because uh, the derivations have been performed there, and also the properties of the chain parameter matrix, how the values are getting are determined, all these things are provided there. So please listen to the lecture videos. Next question is, which one of the following represents the terminal condition at the near end of a three conductor line? Okay, so I showed you the two port network, right, where I will again show you. There was this, yeah, this is the two port network, right, where this is the source side, this was the load side, and here the various currents and voltages are shown. This is Vs, this is Ig, the generator current, then this is the receptor current, Ig0, this is IR0, this is IGL, this is IRL, and at the output we have VGL. Okay, and what are these equations? See, this is V0 is equal to Vs minus Zs I0, right? So obviously, if suppose this is Vg0, right? So what will be Vg0? Vs minus Ig0 Rs, right? You just apply KVL over here. So Vg0, this voltage is Vs minus Is Ig0, right? So that's what is written here. And what is VL? VL is VL plus ZL IL. VL is 0. There is no active source in the load side. So if this is 0, then VL is equal to ZL IL. Obviously, the voltage drop across this resistance is IL RL, right? this voltage. Okay. So this is load side voltage, this is source side voltage. Actually, we are talking about these voltages. Okay, so these are the port voltages. VG0, VR0, these are the port voltages, and this is also the port voltage. So the terminal condition at the near end of the three conductor line, this is the one. V0 is equal to Vs minus Zs I0. Okay, this is the one. So far, is it clear? Okay.
Okay, ma'am.
Okay. So we will go to the next question. Consider a two-way line of equal diameter placed at the same height above the ground plane. Per unit length inductance of the generator is 1 microhenry per meter. If the radius of the receptor is 15 mils, determine the height at which the two-way line is placed. Similar question we have already solved. Here they have told that the height is equal for the generator and the receptor. They are placed at the same height from the ground. So suppose this is the generator and this is the receptor. They are placed at the same height from the ground plane. So let's say the height is h, and here also the height is h. Okay. So here also the image conductors will come. These are image conductors at the same height from the ground plane but in the opposite direction. What is Lg? Lg is given 1 microhenry per meter, and we know how to determine Lg. Lg is mu naught by 2 pi, mu naught by 2 pi ln 2h by r. Because here the height is same and radius is also 15 mils, so I am not referring as Hg, Hr like this. Okay. This is equal to 1. 1 microhenry per meter. Okay. R is given 15 mils. So you will have to first make a convert it to centimeter and then put the rest of the values and you will have to find what is H. Can you solve this and tell me the answer?
Okay, ma'am.
Okay, ma'am. Okay.
Ma'am, while taking the
हाँ
natural log, the anti-log,
हम्म
uh, no, it's the value is too high.
no, you see, you will have to see this is 1 microhenry per meter. So did you take that into account? So here you will have to take basically 1 into 10 power minus 6 either, or what you will have to do if you take it in 1 microhenry like this, then
Yeah,
here what is mu naught? 10 power minus 7. So you just multiply 10 power 6 here. Understood, right?
yes, ma'am.
So the units should be compatible. Yeah.
Option A, ma'am.
Yeah, right. Option A is correct. 2.83 centimeter. So both the generator and receptor, they are at a height of 2.83 centimeter from the ground plane. Okay.
Okay, ma'am.
Let's see the next question. If the separation between the generator and receptor is 3 centimeter, determine the per unit length mutual inductance between generator and receptor considering receptor radius to be 15 mils. Okay, so now you will have to find out what is Lm. Lm expression we know, but this is mu naught by 2 pi. So this is half ln 1 plus 4 HR Hg by a square. So you know all the parameters. This one you can also solve. You try solving this one.
Yes, ma'am.
हाँ.
I'm getting 0.12 microhenry per meter, ma'am.
0.12.
Yes, ma'am.
Okay. That is close. That is close, but I think you should get like very near to the options. So HR and HG, what did you take?
2.83 centimeter.
2.83 for both of them. S
Yes,
is
ma'am.
3 centimeter.
Yes, ma'am.
Yeah, and then okay, rest of the values okay, but okay, so this is the nearest option. But anyway, okay, fine. This is the correct option.
Okay, ma'am.
But how this expression we got that you understood, right? Did you see?
I don't know where. I converted it to meters, right? That's correct, no, ma'am. It's not
Sorry,
necessary.
what?
Both are centimeters. No, no, I'm not sure where I've gone wrong.
Uh, no, like there is not like once you know the expression, nothing much to be done basically. So HRAG is known, ACE is known 3 centimeter, and then I think it depends like how many points after decimal you are taking. All these things also affect the answer. But anyway, like otherwise, like this is just putting the values and calculating the expression, nothing else.
Okay, ma'am.
So what I was telling is that like how this part we got, you understood? Like, did you see the lecture notes? The one thing is calculating the values, but if you just try to remember them blindly, it is a bit difficult because there will be when you will be taking the exam, there will be so many formulas and everything. So just don't blindly memorize the formulas. You try to understand how we are deriving the formulas, how what is the logic behind them, right? Because at that time we will have to solve problems from the whole syllabus, not from a particular chapter or particular topic, right?
Yes, ma'am.
Yeah. So just see how what is the logic. So once you understand that, you can also find it out by your own.
Okay, ma'am.
Okay. Okay, so let's see the next question. Determine the per unit length capacitance of the generator and the mutual capacitance between the generator and receptor. So what we are supposed to find out, we are supposed to find out CG and CM, the generator capacitance and the mutual capacitance. That we can find out easily. So this we also applied in the last discussion. In last week we solved how to find out CG and CM. Once you know LG and LM, you can easily find out what is CM, what is CG. This is LG, LR minus LM square. LG value we know, LM value we also know. And what is V? V is the uh, propagation velocity. So we will assume that this is for free space. So V is equal to the speed of light. So just put the what was LM? LM value was 0.151 microhenry per meter. This is minus 6 and then this is 3 to 10 power 8 where Lg and Lr, both of them have equal value, and it was 1 microhenry per meter square. So this is 1 square and minus 0.151 square. 151 square and they are in microhenry, so outside we will put 10 power minus 12. Is this clear? So you will have to take care of the units as they are in microhenry, and here we have Lm and here we have Lm square. So it's better that you convert everything in Henry or in what in meter. If there is any length, you will have to convert it to meter. Okay. So that's why here I have put 10 power minus 6. Here it is 10 power minus 12. Okay.
Okay, ma'am.
So we will get over here 0.151 by 8.793 in here. 8.793 is basically this quantity 3 square, that is 9 multiplied by this portion, and the powers of 10 we will separate. So here we will get 10 power minus 10. 10 power minus 10. And finally, what is the value? I think 1.7 picofarad, something like this. 1.7 picofarad per meter. Everything is in unit length. Okay. Once we know what is Cm, we can find out what is Cg. So Cg plus Cm. So these values are coming from the L matrix and C matrix. We discussed all this in the last tutorial session. Okay. So if you see the L matrix and C matrix, you will see that there were values like Cg, Cr, Cm. Then in diagonally we had Cm like this. Okay. This is Lg by V square, Lg Lr minus Lm square. Again, all the values we know. This is equal to, I am directly writing the value. You can verify it later. 11.37. This will be in picofarad per meter, and Cm we have already calculated. So Cg will be this minus Cm. This is 9.67 picofarad per meter. Okay, so option C is correct. Okay. Let's see the next question. Calculate the characteristic impedance of any of the wire considering free space medium. Okay. So characteristic impedance GC is equal to LG by CG. See, earlier, if you remember, we told that LC is equal to 1 by C square, right? So you may tell that, okay, like instead of this, I can just write instead of CG. So this will be LG times C, right? C is the speed of light. Okay, so let's not write it C because we are also denoting capacitor as C. So let's write it V. Okay, so if you do LG times V, you will get a different value. Okay, suppose you write like this, this will not be correct. So this is, you multiply LG in the numerator and LG in the denominator. So this becomes LG square and this is LG CG. So this is basically 1 by V square. So if you do LG multiplied by V, where V is the speed of light, so 3 times 10 power 8, and LG was what? LG value was LG value was 1 microhenry per meter, right? So it will be something like 300 ohm. But you see 300 ohm is not even in the options. So you will have to use this one, okay? So you can't use this. So LG and CG, both the values we know. LG value is 1 microhenry per meter. So this is 10 power minus 6. And CG value we just calculated. It was 9.67 picofarad per meter. So 10 power minus 12. Okay. So you just calculate this and you will get something 321.5, something like this.
Yes, ma'am. Got it.
Right?
Yes, ma'am.
Okay. So here option A is closest. 322. Fine. Okay, so these were the questions for today. If you have any doubt, you can ask.
No, ma'am.
Okay, so if you don't have any doubt, I will conclude today's session. Thank you for joining.
Thank you, ma'am.
Thank you. Okay, we will meet next week.
Thank you.
Okay, thank you.